Okay, so now we're gonna move on to some newer stuff, which is sort of like second half of chapter 4 stuff, where you're starting to involve reactions in these mass balances. So first let's go over the extent of reaction method. So a general balance for extent of reaction is gonna be moles out equals moles in plus the stoichiometry times the extent. And let me just break that out in words. So out equals in plus stoichiometry times the extent of the reaction. And our degree of freedom balance is going to look a little different too, since we're starting to involve reactions. So it's number of unknowns plus the number of reactions minus the species balance minus additional info. So we're just adding in the number of reactions. And let's do a short little example concerning extent of reaction method, just to get a hang of it. So we have SO3 and water reacting to form H2SO4. The feed contains water and SO3 at a rate of 180 moles per second. The outlet feed contains 0.3 mole percent SO3, 0.2 mole percent H2O, and the rest, which is 0.5 H2SO4. Write a degree of freedom balance and set up balances to solve this problem using the extent of reaction method. So here we don't know our composition, so we just have some composition of SO3 and the remainder is H2O. I didn't mean to write 3 there. Just X. And we have some molar flow rate in moles per second here. So starting with our degree of freedom balance, we have 2 unknowns. So that's X and N. We have 1 reaction taking place, and we have 3 species balances that we can do. So we have a degree of freedom of 0, so this is totally solvable. And now we're gonna start to set up our balances. So we're gonna be using the extent equations. So for SO3, we have out, so our extent equation is N1 equals Ni naught plus Vi times extent. This is actually supposed to be an I here. Sorry, not a 1. Kind of looks the same though. So for SO3, we have coming out, we have 0.3 times N. And then coming in, we have X times 180. I'm gonna write that the other way around. Just looks better. 180X. And then plus the stoichiometry times the extent. So since SO3 is being used up in this reaction, it's going to be minus the extent of the reaction. And the extent of the reaction is specific to this reaction. And then, so for H2O, we have, coming out, we have 0.2 N is equal to 180, 1 minus X, minus, again, the extent of reaction 1. And the reason this is just reaction 1 and we don't have stoichiometry here is just because there's just 1 mole of SO3 and 1 mole of H2O reacting to form 1 mole of H2SO4. So if we had, like, say this was a different reaction, it was balanced to where, like, 2 moles reacted here, or like 2 moles here or something, we would put 2 here, but it's just 1 mole. So keep that in mind. And then H2SO4, we have that we have 0.5 in coming out, and then we have nothing coming in because we're reacting to form H2SO4, so we don't have any coming into the reactor. And then plus the stoichiometry, since we're forming H2SO4, it's a positive here for the extent. And then you would just solve these for N and X.